Gibson's work on motion perception dove primarily into the study of optics, suggesting that light structures and changes in the optical array provide us with perceptual information. His theory is somewhat complex, and fortunately he broke down optical motion into its components. Optical motion, according to Gibson, deals with the motions of texture gradients or patterns in two-dimensional optical arrays. Gibson suggests two possible descriptions of optical motion. The first of these is to divide the texture gradient into its component parts, first by separating the texture into pairs of coordinate values, and second by separating these coordinate values into successive pairs of values. The second possible description of optical motion is to take the pattern as a given whole. This pattern is inclusive of both perspective transformations as well as families of pattern changes. Focusing primarily on the second description of optical motion, Gibson defines perspective transformations as any form or pattern on one plane which is a projection of a form or pattern lying on some other plane. These projective forms are static and consist of two main types. Central or polar projections are projections in which the line connecting the pairs of forms is near the two planes. Parallel projections are when this point of projection is a great distance from the planes. Having defined these projection types, we can now dive into the concept of motion of perspective transformations. These motions occur when the angle of the first plane of the object is altered relative to the second plane. These object motions then correspond to projected motions. This altering relationship also holds between separate stages in time. Because this relationship is persistent through time, transformational motion can be described as a continuous series of perspective transformations and a relationship between a temporal series or a family of static forms. Perspective transformations can then be described together as families of continuous perspective transformations. In this case, all optical motions result from the rigid physical motions of an object. Gibson presents 6 possible movements of the first plane that correspond to perspective transformations. The first of these 6 parameters is vertical translation, and the second horizontal translation. The third is the enlargement or reduction of the pattern. The fourth and fifth are the horizontal and vertical foreshortening of the pattern, while the sixth is the rotation of the pattern in the first plane. Motion, however, is not always very obvious. For polar parameters 4, 5, and 6, the vertical and horizontal foreshortening and the pattern rotation in the first plane, motion is very difficult to notice. Instead, the observer sees the projective virtual object to have rigid depth motion. For parameter 4, the object moves towards or away from the screen. For parameter 5, the object rotates on a vertical axis, while on parameter 6, the object rotates on a horizontal axis. These 6 parameters of optical motion differ, however, for polar and parallel projections. In the case of parallel projections, parameters 1, 2, and 6, the vertical and horizontal translation, and the rotation in the first plane, are all the same. However, the other 3 parameters differ. The enlargement or reduction vanishes, and rather than vertical or horizontal foreshortening, the observer now sees a horizontal or vertical flattening. Several of the parameters of parallel projections give the appearance of depth rotation. These depth rotations seem to share similarities with Walisch's kinetic depth effect, which refers to the phenomenon that the three-dimensional structural form of an object can only be perceived when the object is rotating. A demo of this effect can be found on the web page. The rotations of depth are characterized by the ambiguity of direction of rotation and also the spontaneous reversals of direction. This ambiguity, however, only arises when the transformations are from parallel projections. Gibson's concepts of optical motions are complex and can be rather confusing. Hopefully, this video provided some clarification of Gibson's ideas. If not, his article, Optical Motions and Transformations as Stimuli for Visual Perception, can be found using the link below.